The battery industry is one of the largest chemical industries to date because everything is going digital and portable. Batteries are a device used to generate electrical energy. It powers cell phones, remote controls, flashlights, and helps cars to start easily. They exist in our cars, laptops, CD players, and other electronic appliances. A battery is essentially a can full of chemicals that produces electrons. The basic structure of a battery includes two terminals. One terminal is marked positive, while the other is marked negative. In a normal flashlight batteries, the ends of the battery are the terminals. In a large car battery, they are two heavy lead posts that act as terminals. Electrons collect on the negative terminal of the battery. When a wire is connected between the negative and positive terminals, the electrons will flow from the negative to positive terminals. Normally, some type of load is connected to the battery using the wire. The load might be something like a light bulb, a motor, or electronic circuit like a radio. You have two cells. One cell has a copper solution and the copper electrode, and the other cell has the aluminum solution with the aluminum electrode. Free electrons flow from the anode to the cathode. The aluminum is the anode, while the copper is the cathode. They pull excess ions from the salt bridge in order to keep the electrodes neutrally charged and allow the electrons to flow freely without getting pushed back from the increasing negative charge on the cathode. Things you will need: chemicals, cupric sulfate, aluminum ammonium sulfate, sodium chloride, water, glassware, two flask, two beakers, one graduated cylinder, two glass stir rods. Other: two scoops, filter paper scraps, scissors, alligator clips, copper electrode, aluminum electrode, multimeter. Safety equipment: gloves and goggles. To begin with, we need aluminum ammonium sulfate. Use weighing paper to measure out 1 gram of aluminum ammonium sulfate. Measure out 100 milliliters of purified water. Add the aluminum ammonium sulfate to 100 ml of water to make a 0.042 molar solution. Then stir. Then add it to a flask to make 1 cell. Next, we need cupric sulfate. Use weighing paper to measure out 1.5 grams of cupric sulfate. Then measure out 100 milliliters of purified water. Add the cupric sulfate to the 100 milliliters of water to make a 0.094 molar solution. Stir. It's going to take a lot of stirring. Then add to a flask to make your last cell. Next, we need sodium chloride to make a saturated ionic solution by mixing water and salt. Then make a salt bridge by cutting a strip out of some scrap filter paper. Then soak the paper in your saturated ionic solution. Take the electrodes and connect them to the multimeter using alligator clips. Then put them in the cells. Add your salt bridge between the two cells. The max voltage I got during the experiment was 0.702 volts. When you do the math, the theoretical maximum voltage you can pull from this cell should be 1.82 volts.